In my testimony today, I'd like to provide the committee with some key actions related to the cement and concrete industries that will accelerate us on the path to sustainability in the industrial manufacturing sector. For background, cement is the powdery substance that's mixed with water and aggregates to make concrete. If you didn't realize there was a difference between cement and concrete, you can join my beloved mother in that esteemed club. Although cement and concrete have different manufacturing processes and emission profiles, they're inherently linked as end-use building material whose impacts other emissions such as building energy consumption or vehicle fuel consumption on pavements. Thus, it's important to consider the embodied emissions for these materials in the context of their full life cycle. Furthermore, concrete is the most used building material in the world for a reason. It's a relatively low cost and low environmental footprint material that provides critical functionality for buildings and infrastructure. It's necessary to meet societal goals for sustainable development. There are 4 primary levers for reducing cement production CO2 emissions. 1, improving the energy efficiency of the cement plant. 2, switching to alternative fuels that are less carbon intensive than conventional fuels, such as biomass and waste materials. 3, increasing the use of low carbon materials in the production of blended cements. And 4, using emergent carbon capture and utilization and storage technologies, including in the production of new building materials. A technology roadmap for the global cement industry estimated that meeting targets for a maximum 2 degrees C global temperature increase would require a 24% reduction in cement industry CO2 emissions by 2050, with CCUS accounting for 48% of emissions reductions, followed by use of blended cements at 37%. There are fewer CO2 reduction opportunities associated with thermal energy efficiency or switching to alternative fuels, and thus they only accounted for 15% of cumulative CO2 reductions. Nevertheless, there are several opportunities to improve energy efficiency and increase use of alternative fuels, and the cement industry in the U.S. has made significant strides towards these goals. However, regulatory programs are often barriers to making additional improvements, and there are some specific programs and suggested modifications that are detailed in my written testimony. Cement production is unique from most other industrial processes in that it has emissions associated with energy generation and the production process. Thus, even if zero or low carbon fuels can be used, emissions will still be a fundamental part of the process. As a consequence, CCUS is necessary to meet deep decarbonization goals, and pilot programs in the cement industry are underway across the world. Fortunately, there are several companies that are demonstrating how captured carbon may be used to produce binders and aggregates, thereby enabling circularity for these emissions. However, cost is a significant barrier to the implementation of carbon capture technologies at cement plants in terms of capital costs, and the adoption of carbon utilizing materials in terms of higher product costs in the building material marketplace. Thus, there are significant opportunities for Congress to provide targeted CCUS research, development, and deployment funding that is specific to the cement sector, and incentives for adoption of innovative technologies and materials. Increasing the adoption of blended or alternative binders will require overcoming the risk aversion of engineers specifying concrete. Engineers typically rely on prescriptive-based specifications that detail the types and limits of materials that can be used in concrete mixtures. In addition, there's a significant burden of proof to demonstrate that new low-carbon materials will meet long-term structural and durability requirements. Supporting a shift to performance-based specifications for concrete would spur innovation in the design of low-carbon concrete mixtures. Sponsoring research on the long-term structural and durability performance of concretes using blended or alternative cements will help to mitigate perceived risk by engineers. As you can see, there are steps Congress, industry, and academia can take together that would ensure the continued role of cement and concrete in sustainable development. Mr. Chairman and members of the committee, we're ready to work with you to pursue the path toward the goal of a clean and sustainable economy together. Thank you.